Welcome to Unstuck. Today, the exploit that has drained hundreds of millions across DeFi. Price oracle manipulation. A lender trusted the trading pool's live price to value your collateral. So, an attacker flash borrowed a fortune, bent that price for a single transaction, and borrowed the entire pool against collateral worth almost nothing. We'll see the one line that trusted the wrong price, run the attack ourselves by hand in Remix, prove it with the Foundry tests, watch it on a real block explorer, and fix it by swapping the oracle. Here's the heart of it, how the lender decides what your collateral is worth. To let you borrow, it asks an oracle for the price, and this oracle just returns the spot price from a trading pool, the ratio of its two reserves, right now, this instant. Read that carefully, because trusting a live tradable price is the entire bug. Zach, first, what an oracle is. A smart contract can't see prices on its own, so it asks an oracle, a contract that reports what something is worth. A lender needs one to answer a simple question. Your collateral is worth how much? So how much may you borrow? If that price is honest, everything is fine. But if the attacker can move the price, they can lie to the lender about what their collateral is worth. Here's the whole attack as a flow. So follow the numbers. 1. The attacker takes a giant flash loan, borrowed and repaid inside the same transaction. 2. They dump it into the trading pool in one huge swap, which skews the reserves and spikes the collateral's spot price. In our demo, 100 times over. 3. The lender's oracle reads that spot price and now believes the collateral is worth a fortune. 4. The attacker deposits a tiny bit of that collateral and borrows the entire pool against a fake price. 5. They reverse the swap to repay the flash loan and keep the pool. The price was a lie for exactly one transaction, and that was enough. Back to the code, the vulnerable path highlighted. When you borrow, the lender works out how much your collateral is worth by calling oracle.price. And that oracle returns am.spotprice, the pool's instantaneous reserve ratio. That's the flow. A spot price is just a number a big trade can move. Feed it a manipulated pool, and it will happily report a manipulated price. And here's the fix, the same oracle, but reading from a trusted manipulation-resistant source, a chain-link feed, or a time-weighted average that no single transaction can move. Same lender, same borrow logic, but now price returns a value the attacker cannot bend. Swap this one component and the whole attack falls apart. Let's watch it happen, then prove the fix stops it. Let's do this attack by hand in Remix, so you see every single click. On the right is our attacker contract, which spins up the trading pool, the spot price oracle, and the lender that trusts it. We deploy the attacker. Its constructor builds the pool with 1,000 units of collateral and $1 million of reserves, an honest price of $1,000 each, and the lender holding $1 million ready to lend against that oracle. First, the honest price. We click oracle price and it reads 1,000. 1 unit of collateral is worth $1,000, exactly what the pool says when nobody has touched it. And how much is in the lender? We click pool liquidity and it is $1 million. That is the price, the money the attacker wants to walk away with. Now the manipulation, we click manipulate. Behind that one click, the attacker's flash loaned dollars slam into the pool in a single giant swap, draining its collateral side and leaving the reserves wildly skewed. Now we check the price again. We click oracle price and it now reads 100,000. The same collateral the oracle valued at 1,000 a moment ago, it now swears is worth 100,000, 100 times higher from a single swap. Nothing about the collateral changed, only the pool did. Here's the theft. We click drain. In one call, the attacker deposits just 20 units of collateral, and because the oracle now values each one at 100,000, the lender lets them borrow the entire pool. Check the pool. Now we click pool liquidities and it reads 0. The whole pool drained, borrowed against collateral that is really worth almost nothing. So what did they walk away with? We click my loot and it reads $1 million, 20 units of collateral honestly worth 20,000, borrowed $1 million and never came back. The lender is left holding a loan it can never recover. We did all that by hand. Now let's prove it with a test and read it line by line. It deploys the attacker, then asserts the honest price is 1,000 and the pool holds $1 million. Then it calls manipulate and asserts the price has jumped to 100,000. Then it calls drain and asserts two things. The pool ends at 0 and the attacker's loot is $1 million. Every manual step we just did now pinned down by code. And there is the result. Also, honest price 1,000, pool $1 million, after manipulate 100,000. After drain, the pool is 0 and the attacker's loot is $1 million. It passes, which means every assertion held, so the drain is real, exact and repeatable. Then now the fix, the same test but against the lender using the trusted oracle. It calls manipulate, where then asserts the price is still 1,000, the swap moved the pool but not the oracle. Then it wraps the drain call in expect revert, it demands the attack fail with under collateralized, and afterwards it asserts the pool never moved, still $1 million. It passes. The overborrow reverted exactly as expected, and the pool stayed at $1 million. So swapping one oracle doesn't just look safer, it provably blocks the exact attack that emptied the pool. And this is not just a local sandbox. We deployed the very same attacker and lender to the Sepolia network and verified them on Etherscan. Source code verified, exact match. Anyone can read the spot price oracle for themselves. This is the drain as a real transaction. Etherscan decodes it as a call to drain and it succeeds. On a live chain, the attacker borrows the whole pool against the manipulated price. The theft recorded permanently in a block you can click through. Here is that same drain but against the fixed lender on the same network. Status failed. Because the trusted oracle held the price steady, the overborrow reverted on chain exactly as our test predicted. A real decoded failed transaction and the fix proven in public. Side by side, the old lender reads a live spot price, so a flash loan bends it and the pool drains. The fixed lender reads a trusted average price, so the same swap changes nothing and the borrow reverts. The rule underneath is worth memorizing. Never price collateral with a number a single trade can move. The takeaways. Never use a raw trading pool spot price as an oracle. It's manipulable in a single transaction. Use a decentralized feed like Chainlink or a time-weighted average that smooths out single block swaps. Assume any attacker can flash borrow hundreds of millions for free within one transaction. And whenever a contract reads a price, ask, could someone move this right before they use it? Let's recap. The lender valued collateral with a trading pool spot price. The attacker flash borrowed a fortune, swapped to spike that price 100-fold, then deposited a little collateral and borrowed the entire pool against the lie, reversing the swap to repay the loan. The fix is to read the price from a manipulation-resistant oracle. We saw it by hand in Remix, in the Foundry tests, and live on Etherscan. A quick note, if these breakdowns help you ship safer contracts, the wallet is on screen and there is a Ko-fi link in the description. Every tip funds the next reconstruction. Thank you. Check on your turn. Comment the hack you want me to reconstruct next and I'll build it live, just like this one. If it helped, hit like and subscribe so you catch the next one. This was a genericized reconstruction, the lesson, not the names. Thanks for watching and I'll see you in the next one.